You are about to hear something that identifies a permanent, unyielding law ruling the dynamic choreography of the cosmos. For generations, people looked out at the night sky and assumed that the rotation of planets, stars, and galaxies was just a random, beautiful coincidence, imagining that each cosmic object simply received a unique, accidental twist during its creation. This digital reconstruction reveals that the underlying physics is completely unified and mathematically unavoidable. The rotation of the universe is not an accident. Spinning is the foundational, default setting of physical reality. It is the direct consequence of a fundamental law of physics that forces every collapsing cloud of matter to whirl faster and faster as it builds the architecture of space. Our slow journey into this rotation engine begins billions of years ago inside a primordial nebula. Galaxies, stars, and planetary systems all start their lives exactly the same way, as colossal, disorganized clouds of cold gas and cosmic dust drifting lazily through space. To the untrained eye, these stellar nurseries appear completely still and static. However, a major scientific disruption to this illusion of stillness occurs when you analyze the cloud at a microscopic level. Because of the turbulent aftermath of the Big Bang and the passing shockwaves of distant exploding stars, the individual particles inside the gas cloud are continuously jostled, moving around in a chaotic, random scramble. In the vast history of the universe, no gas cloud has ever been perfectly, absolutely still. Every cloud possesses a tiny, net amount of collective motion swirling in one specific direction, a structural metric known as angular momentum. The true mind-bending transformation manifests when gravity activates within this cloud. If the gas cloud becomes dense enough, its own gravity begins to pull all the scattered gas and dust particles inward toward a single, common center of mass, attempting to crush the immense cloud down to build a star. As the cloud collapses, it must obey an ironclad, mathematical law of physics known as the conservation of angular momentum. This law dictates that the total amount of rotational energy inside a closed system must remain completely constant. If the physical size of an object shrinks, its rotational speed must automatically increase to balance the cosmic equation. To visualize this orbital acceleration in your mind, imagine a figure skater spinning slowly on ice with their arms stretched out wide. The moment the skater pulls their arms tightly inward toward their chest, they don't stop spinning. Instead, they instantly and aggressively accelerate, whirling around at a blindingly fast speed. The collapsing gas cloud executes this exact same physical trick across millions of kilometers of space. As gravity pulls the massive cloud inward from a scale of light years down to the compact size of a solar system, the tiny, subtle, random motion of the original particles is compressed and amplified by a factor of millions. The cloud begins to spin with absolute, raging fury. This extreme rotational acceleration completely reshapes the geometry of the matter. As the cloud spins faster and faster, a powerful kinetic force pushes out against gravity along the equator of the spin. While the top and bottom of the cloud can still collapse cleanly toward the center to form a central star, the material along the sides is flattened out by the rotation, transforming the giant sphere into a flat, rapidly spinning pancake of material known as a protoplanetary disk. Every single planet, moon, and asteroid in our solar system was forged inside this spinning sheet of leftovers. Because the original disk was already spinning in a clockwise or counterclockwise direction, every planet that materialized out of the debris naturally inherited that exact same rotational momentum, continuing to spin on its axis and orbit around the central sun long after the original cloud vanished. Every slow revelation of this physical law introduces a fascinating, deeply humbling realization. The spin of our world is a direct, living echo from the dawn of creation. Deeper implications suggest that rotation is the primary defense mechanism of cosmic structures. Without the outward push generated by angular momentum, gravity would be an absolute, unhindered tyrant. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. The Earth would fall directly into the Sun would slide straight into the supermassive black hole at the center of the Milky Way, and all the diverse matter in the cosmos would be instantly crushed into a single, dead singularity. The universe continues to exist only because it refuses to stop spinning. We invite a calm appreciation for this ultimate cosmic clockwork. The relentless spinning of the universe did not materialize by chance. It was woven into the very fabric of mass and motion. By looking slowly at the conservation of angular momentum and tracking the long collapse of ancient stardust, humanity is unlocking the primary rhythm that drives reality, proving that the rotation of our tiny blue home is just a single, precious verse inside a grand and beautifully infinite symphony of motion. Rotation is a fundamental property that defines the motion of everything across the cosmos. This continuous spinning motion appears in every single structure we observe throughout the deep universe. Astronomers track this universal rotation by analyzing the shifts of light from distant moving objects. Galaxies turn like massive wheels drifting across the dark fabric of the cosmic web. Stars rotate on their axes, while planets circle around them in predictable eternal paths. Even the smallest particles of dust in interstellar space possess their own quiet spin. This universal movement is not accidental, but rather a direct result of ancient physics. The conservation of angular momentum dictates that spinning things must keep spinning forever. As large clouds of gas collapsed billions of years ago, they began rotating faster. Every spinning object in space today carries the memory of that initial cosmic collapse. We see this motion everywhere we look with our most advanced space telescopes. The universe seems to prefer rotation over perfect stillness in almost every single scenario. Matter gathers together and inevitably begins to dance around a central point of gravity. This phenomenon happens on the scale of tiny moons and massive galactic superclusters. Yet the exact origin of all this primordial angular momentum remains slightly mysterious. Scientists continue to study the cosmic microwave background for early signs of primordial rotation. This ancient light offers a faint glimpse into how the universe first began turning. The movement is gentle but absolute, holding galaxies together over billions of years of time. You can observe this truth in the quiet geometry of every spiral galaxy. To understand why this happens, we must look at how structure forms in space. Nothing in the universe exists in a state of perfect and total isolation. As gravity pulls matter together from different directions, forces naturally become somewhat unequal. This slight asymmetry creates a turning force that initiates a permanent spinning motion. Once a system begins to spin, it cannot stop unless an outside force intervenes. In the vacuum of space, there is no friction to slow things down. The rotation becomes a permanent feature of the object as it drifts along. This brings us to a closer look at our own cosmic neighborhood. Consider the familiar motion of an ordinary playground roundabout spinning in a quiet park. If you push it gently, it rotates around a central metal axle, quite predictably. You can walk around it in a few short steps, measuring its small boundaries. This everyday object requires constant energy to keep moving against the friction of air. In the vast emptiness of space, however, things behave much more permanently. A planet spinning on its axis does not encounter any air resistance at all. It requires no additional energy to maintain its rotation across vast epochs of time. The Earth has been turning steadily for over 4 billion years without stopping. This slow rotation dictates the rhythm of our days and our quiet nights. Imagine walking along the equator of a world spinning smoothly through the dark. Your pace would feel completely stable, even though you are moving remarkably fast. The scale of the planet masks the true speed of its internal rotation. This gentle turning creates a reliable cycle that living things have adapted to historically. Humans have watched the stars rise and set for many thousands of years. They used this predictable rotation to navigate oceans and mark the passing seasons. We naturally view this movement as a permanent anchor of our daily existence. It is a human-scale reflection of a rule that governs the entire cosmos. Every object you touch has a center of mass around which it could balance. If you toss a simple stick into the air, it naturally rotates as it falls. It finds its own center and spins around that point without any effort. Space objects do the exact same thing on a much grander physical scale. They find their balance while drifting through the immense freezing vacuum of space. This natural tendency to spin keeps structures stable over incredibly long lifetimes. Without this motion, planets would simply collapse directly into their parent stars. The spin creates a balance that allows complexity to emerge over time. To understand how this balance scales upward, we must move further outward. When you look closely at that simple tumbling stick, you are witnessing a fundamental law of physics operating in miniature. The stick does not wobble randomly without purpose or rule, but instead organizes its entire physical form around a singular invisible coordinate. This point, known as the center of mass, acts as an internal anchor for every molecule that comprises the object. Even if the stick is uneven thick on one end and narrow on the other, the natural geometry of physics perfectly calculates the precise balance point. As it travels through the air, the heavier end swings in a tight, predictable circle, while the lighter end traces a wider path around the same shared center. This behavior is elegant, completely effortless, and entirely automatic, requiring no external calculation or deliberate steering force. In our atmosphere, air resistance eventually drains this momentum, bringing the stick to rest upon the ground beneath your feet. In the absolute vacuum of interstellar space, however, there is nothing to rob an object of its rotational kinetic energy. A stray piece of cosmic rock tumbling through the dark will continue its dance for trillions of years without ever slowing down a single fraction of a degree. We can scale this perspective up to the enormous boulders that wander silently within the asteroid belt between Mars and Jupiter. These irregular chunks of primordial iron and stone are never perfectly round or symmetrical like modern planetary bodies. They resemble jagged teeth, torn fragments, or rough mountain peaks drifting blindly through the freezing solar landscape. When astronomers watch these ancient rocks using specialized light detectors, they observe a continuous rhythmic brightening and dimming of their reflected sunlight. This cyclic variation occurs because the odd shapes are rotating steadily around their individual centers of mass, presenting different surfaces to our distant cameras. Some of these asteroids take hours to complete a single turn, while others spin so rapidly that they sit right on the edge of flying completely apart. Yet each one carries the exact signature of balance that you can observe in a falling stick or a thrown stone. This motion is not a sign of chaos, but rather the physical method by which matter stabilizes itself within an environment governed by gravity. As we expand our awareness to a slightly larger human scale, we can look at the mechanical structure of our own bodies moving through space. If an astronaut steps out of a spacecraft into the true weightless void of low Earth orbit, they must move with profound care and deliberate intention. A sudden sharp push against the metal hull of the ship can easily introduce an unwanted turning force to their torso. Without solid ground to provide a counterweight, the human form will begin to rotate helplessly around its own pelvis, which functions as our anatomical center of mass. The astronaut will experience a slow, disorienting tumble, watching the vast blue curve of the Earth and the deep black of the cosmos alternate smoothly across their field of view. To stop this movement, they cannot simply flail their limbs, because every internal muscle movement merely shifts their weight without altering their total angular momentum. They must rely on specialized gas thrusters attached to their suits to apply an equal and opposite force to steady their position. This delicate orbital reality illustrates how firmly our physical existence is bound to the rigid laws of rotational mechanics. This same physics applies directly to the formation of small moons that circle the larger planets in our solar system. Consider Mars and its two tiny companions, Phobos and Deimos, which are small, heavily cratered bodies that resemble captured asteroids more than proper spherical worlds. Phobos orbits incredibly close to the red planet, completing 3 full journeys around Mars in a single Martian day. Because it is so close, the intense gravitational pull of the planet creates strong tidal forces that interact with the internal mass of the Moon. This interaction has locked the rotation of Phobos, so that it always shows the exact same rocky face to the surface below. This phenomenon, known as tidal locking, is another beautiful example of rotational balance settling into a permanent configuration over immense stretches of geological time. The Moon still spins on its axis, but its rotational period perfectly matches its orbital period around the parent world. This creates a quiet, stable equilibrium that will persist until the orbit itself slowly decays millions of years in the future. When you think about walking across the surface of the Earth, you are interacting with this giant web of rotational forces every single moment. We do not feel the planet spinning beneath our boots, because we are moving along with it at the exact same constant speed. The atmosphere, the oceans, the mountains, and our cities are all locked into this grand planetary rotation together like a single cohesive unit. Historically, early human cultures believed that the ground was completely stationary, while the heavens revolved around them in a magnificent celestial sphere. It took centuries of careful observation, detailed mathematical tracking, and courageous scientific reasoning to invert this ancient perspective. We now understand that the rising of the sun is a quiet illusion generated by our world, turning eastward into the warm morning light. This realization does not diminish our place in the cosmos, but rather grounds us within a massive physical mechanism that operates continuously. To further appreciate the scale of this planetary balance, we can observe how the shape of a world is physically altered by its spin. The Earth is not a perfect geometric sphere, but rather an oblate spheroid, which means it is slightly flattened at the poles and bulges outward at the equator. This subtle shape distortion is caused by the outward centrifugal effect generated by its 24-hour rotation period. If you were to stand at the equator, you would actually be slightly further away from the center of the Earth than if you were standing at the freezing North Pole. This equatorial bulge represents a vast accumulation of rock and water that has shifted outward over billions of years to achieve a state of hydrostatic equilibrium. The planet has literally sculpted its own massive body to balance the competing forces of inward gravity and outward rotation. This self-regulating geometry ensures that the oceans do not pool massively at the poles, but remain distributed in a way that allows stable climates to persist across continents. On a world like Jupiter, this rotational deformation is far more dramatic and easily visible through a modest backyard telescope. Jupiter is a colossal gas giant with a mass greater than all the other planets in the solar system combined. Despite its immense size, it spins on its axis faster than any other world, completing a full rotation in just under 10 hours. When you view Jupiter through a lens, you can see that it looks distinctly oval, squashed from top to bottom by the sheer speed of its turning. This furious spin creates powerful internal currents within its deep hydrogen atmosphere, generating the colorful bands of cloud and the massive storms that define its surface. The Great Red Spot, a hurricane twice the size of Earth, has been spinning counterclockwise for hundreds of years, driven by these intense rotational energy shears. The scale of Jupiter reminds us that rotation is not a passive background feature, but an active dynamic force capable of shaping global landscapes. As we step back further to view our solar system as a whole, we see that this principle of rotational balance operates between worlds as well. The planets do not orbit the Sun in perfectly chaotic independent trajectories, but occupy a relatively flat plane called the ecliptic. This flat arrangement is a direct relic of the original spinning disk of gas and dust that formed the entire system 5 billion years ago. If the primordial cloud had not been rotating, the material would have fallen straight down into a central point, forming a lone star without any accompanying planets. The initial spin created an outward resistance that held the material back, allowing it to cool, clump together, and form the family of worlds we inhabit today. Every planet, from tiny Mercury to distant Neptune, moves within this shared geometric groove, carrying the ancient momentum of that birth disk. This brings us to consider the immense spaces that separate these spinning worlds from one another. Between the orbits of the planets lies the interplanetary medium, a nearly empty void filled with sparse solar wind particles and microscopic grains of cosmic dust. Even these tiny dust grains, which are smaller than a single speck of pollen, carry their own individual rotational signatures. As they are struck by the streaming photons of sunlight, they experience a subtle force called the Yarkovsky effect, which can alter their spin speeds over millions of years. This tiny pressure can cause dust particles to slowly spiral inward toward the sun, or outward into the deep dark. It is a striking reminder that no object is too small or too isolated to escape the universal laws of rotation and light. The entire fabric of space is alive with these overlapping motions, creating a complex tapestry of balance that spans across every imaginable scale of distance. Imagine sitting quietly on a dark night, far away from the glowing lights of modern cities, looking up at the faint band of the Milky Way. Every single point of light you see is a massive sun, and every one of those suns is turning on its own internal axis. Some are old and slow like our own parent star, while others are young blue giants spinning so frantically that they are tearing their own outer layers away. This collective motion forms a grand harmony that maintains the structure of our galactic neighborhood. We are safely nested within this hierarchy of movement, completely protected by the absolute laws of physics. The stability of our daily lives is a direct consequence of these massive cosmic balances working perfectly in the background. As we contemplate this grand arrangement, our minds naturally settle into a peaceful state of calm reflection. The transition from the small scale of everyday objects to the grand scale of planetary bodies happens so smoothly that we barely notice the shift. The same mathematical equations that govern the motion of a spinning playground roundabout can be used to predict the rotation of a distant gas giant or a spinning moon. This universality of physical law provides a profound sense of comfort and predictability in a vast and uncertain universe. We do not need to fear the unknown depths of space because the basic rules of matter and motion remain completely constant wherever we look. The spin we observe in our own small corner of reality is the exact same spin that guides the furthest galaxies at the visible edge of the cosmos. It is an enduring thread that binds the entire universe together into a single, understandable system. As you continue to reflect on these turning worlds, the boundaries between yourself and the wider universe begin to soften gently. You are a passenger on a beautiful blue sphere that is turning through the dark, carrying you safely along its orbital path. The rhythm of this rotation is steady, unchanging, and completely reliable, creating a secure environment for life to thrive. There is no need to worry about the immensity of the vacuum or the vast distances between stars, because the laws of balance are always holding everything securely in place. The spin creates a continuous, gentle stability that allows the complexity of thoughts, dreams, and rest to emerge over time. With this comforting thought, we can allow our awareness to move even further outward into the wider spaces of the cosmic landscape. To understand how this balance scales upward beyond individual solar systems, we must begin to look at the interactions between multiple star systems. Many stars in our galaxy do not live alone like our Sun, but are born in pairs or small groups known as binary and multiple star systems. These sibling stars orbit around a common center of mass, falling into a permanent gravitational dance that can last for billions of years. As they circle each other, their individual rotations are often influenced by their neighbor's presence, creating a complex choreography of motion. They pull and tug at each other's bodies, stretching their spheres into elongated shapes and exchanging material across the empty space between them. This stellar interaction is a beautiful extension of the balancing principle operating on a scale that defies easy human imagination. As we watch these binary systems from our distant vantage point on Earth, we gain a deeper appreciation for the role of rotation in maintaining cosmic structure. Without the outward motion generated by their orbital paths, these stars would quickly collide and merge into a single chaotic mass. The spin creates the necessary space and distance for them to coexist peacefully side by side, illuminating the night with their dual fires. This balance is a universal theme that repeats itself across every level of cosmic organization, from the smallest atom to the grandest galaxy. The tendency to turn is the universe's natural defense against complete gravitational collapse. It is the force that keeps the lights of heaven burning bright and clear through the long, dark epochs of time. This understanding allows us to release any lingering feelings of anxiety or uncertainty about our place in the world. We are not drifting randomly through a hostile and chaotic void, but are part of a beautifully ordered system that balances itself perfectly at every turn. The constant, steady rotation of our world provides a reliable foundation for every experience we have. As the night deepens and the stars continue their silent journey across the sky, you can rest completely secure in the knowledge that the universe is functioning exactly as it should. The turning will continue uninterrupted, guiding us smoothly into tomorrow while we sleep deeply under the watchful eye of the turning cosmos. The motion is endless, gentle, and profoundly peaceful, fading softly into the quiet background of our thoughts as we drift away. Now, let us move outward to the scale of our immediate solar system. Each planet moves in a circular path while simultaneously spinning like a top. The Sun at the center rotates smoothly, taking about 25 days to turn. This motion began when a cloud of gas collapsed to form our star. As the cloud shrank, it naturally spun faster and faster to conserve its energy. This is similar to an ice skater drawing their arms inward during a spin. The material that did not fall into the sun formed a flat disk. This rotating disk of dust and gas eventually clumped together into planets. The planets inherited this original spinning motion from the ancient rotating disk. Earth spins counterclockwise, and most of its neighbors follow the exact same direction. There are curious exceptions like Venus, which turns very slowly backward for reasons unknown. Astronomers suspect a massive ancient collision might have altered its original rotation completely. This uncertainty reminds us that the history of space is filled with random events. We accept these planetary anomalies as part of the complex evolution of solar systems. The general rule of rotation remains dominant across the entire planetary family. This brings us to a larger scale as we contemplate the wider stellar neighborhood. Millions of stars are drifting through the local interstellar cloud, all spinning quietly. Some stars spin so rapidly that they flatten slightly at their poles. These fast rotators fling material out into space, creating glowing rings of gas. Other stars have slowed down over time due to powerful stellar winds. The loss of matter gradually drains their rotational energy over billions of years. This slow braking mechanism is a gentle reminder of shifting cosmic balances. We observe these stellar rotations by watching dark star spots move across their surfaces. Astronomers use these patterns to calculate the exact speed of distant suns. The variety of rotational speeds presents a continuous puzzle for modern astrophysics. Each star tells a unique story of formation and gradual decay. We accept that our understanding of these stellar lifespans remains incomplete. The mystery of their precise rotational journeys adds to the quiet depth of space. To understand how these stars coordinate their movements, we need to step back further. When we look at our own sun, we see a grand sphere of glowing plasma that does not turn as a single solid object. Because it is composed of superheated gas and ionized matter, its equator rotates much faster than its icy polar regions. This phenomenon, known as differential rotation, stretches and twists the immense magnetic fields hidden deep within the stellar interior. Over a cycle lasting roughly 11 years, these knotted magnetic lines burst through the brilliant surface, creating cooler, darker regions called sunspots. By tracking the steady march of these dark blemishes across the blinding solar disk, astronomers historically unlocked the secrets of solar spin. When we apply this identical method to the distant night sky using advanced space telescopes, we observe similar spots drifting across the faces of alien suns. This continuous tracking reveals an astonishing diversity of rotational speeds across the stellar population of our galaxy. Some mature stars turn with a slow, majestic dignity, taking months to complete a single revolution, while newborn stars whirl with terrifying speed, completing a full turn in a matter of hours. This wide variation in spin speeds is directly connected to the complex life history of each individual star. When a stellar body first condenses out of a cold interstellar cloud of hydrogen gas, it inherits a massive amount of primordial rotation from its parent environment. This youthful spin is often so intense that it threatens to tear the infant star apart before it can even properly ignite its nuclear furnace. As the star matures over millions of years, it begins to shed this excess rotational energy through a subtle process called magnetic braking. The star ejects a steady stream of charged particles, known as a stellar wind, into the surrounding vacuum of space. These escaping particles are trapped along the star's sprawling magnetic field lines, acting like invisible weighted ropes flailing outward into the dark. As this matter escapes into the void, it drains angular momentum away from the stellar core, slowly calming the frantic whirl of youth into a stable middle age. This gentle slowing mechanism is a universal law that ensures stars can live for billions of years without destroying themselves through sheer mechanical force. As we look deeper into the stellar neighborhood, we discover that this slowing process does not always follow a perfectly predictable path. Some stars possess immense hidden planets, orbiting so close to their surfaces that they complete an entire year in less than a single Earth day. These massive hot gas giants exert powerful gravitational tidal forces upon their parent stars, creating a deep physical bulge in the stellar plasma. This interaction can reverse the natural aging process of stellar spin by dumping orbital energy back into the star's rotation, a cosmic phenomenon known as tidal spin-up. The aging star is effectively rejuvenated by its companion, forced to spin faster and faster as the doomed planet slowly spirals inward toward its ultimate destruction. This complex relationship between stars and their planetary families introduces a profound layer of uncertainty into our neat astrophysical models. We observe these accelerated suns with a sense of quiet wonder, realizing that every star we catalogue carries a highly individualized story written in the rhythm of its spin. This brings us to a larger scale, where we contemplate the strange dead remnants of stars that have long since exhausted their nuclear fuel. When a massive star reaches the end of its life, it undergoes a catastrophic supernova explosion, blowing its outer layers into space, while its core collapses inward under the absolute weight of gravity. If the remaining core is between 1 and 3 times the mass of our Sun, it crushes itself down into an incredibly dense ball of neutrons, only a few miles wide. Because the immense mass of the original stellar core is compressed into such a tiny space, the conservation of angular momentum forces this newborn neutron star to spin at a dizzying rate. These bizarre objects, known as pulsars, can rotate hundreds of times every single second, beaming intense cones of radiation out into the cosmic night, like a cosmic lighthouse. The precision of this rotation is so absolute that their pulses can be used as highly accurate cosmic clocks, navigating future travelers through the interstellar void. They will simply pass by each other like ghosts in a hallway, eventually settling into a new, larger arrangement. The Milky Way is a place of constant, quiet recycling. In the cold clouds of gas and dust between the stars, gravity is always at work. It pulls the dust together until it grows hot and dense, eventually igniting into a new star. When those stars die, they exhale their elements back into the void: carbon, oxygen, iron, the very ingredients that eventually formed the Earth and everything on it. We are literally made of the recycled breaths of ancient stars in this local neighborhood. It is a closed system of cosmic elegance. However, as we look further out, we realize that the Milky Way is part of a small, relatively lonely cluster called the Local Group. We have a few dozen neighbors, most of them small dwarf galaxies that look like tattered clouds. We are the big fish in a small pond. But if we were to travel toward the constellation of Virgo, or further still toward Serpens, the density of the universe begins to change. The ponds become lakes, and the lakes become oceans. When we look at the Milky Way from the outside, it is a beautiful, thin disk with graceful arms. It is a fresh galaxy, still forming stars, still vibrant with the blue light of youth in its spiral limbs. It is a place of birth and movement. But the giants we are searching for, the IC 1101s of the deep, have long since moved past this phase. They have stopped the frantic business of star birth. They have become something more singular, more monolithic. Imagine the Milky Way as a single sheet of paper. To represent the scale of the largest galaxy found, you would need to stack thousands of sheets of paper until they reached the height of a tall building. The sheer volume of space occupied by our neighbor is a drop in the bucket compared to the volumes we are about to explore. Our local neighborhood is a sanctuary of sorts, a quiet, predictable corner of the cosmos, where the light of 200 billion suns provides a sense of familiar warmth. But the horizon is calling. Beyond the edges of our dark matter halo, beyond the reach of the Andromeda Galaxy's gravity, lies the Great Attractor and the vast clusters of the Laniakea supercluster. We are moving away from the spiral life, the life of arms and disks, and toward the elliptical life, the life of pure, concentrated mass. In this transition, we leave behind the blue stars and the gas clouds. We move toward a region where the stars are older, redder, and packed together in densities that would make our night sky look like a solid wall of gold. We are moving toward the center of the Abell 2029 cluster. If the Milky Way is a suburban home, the environment around IC 1101 is a sprawling, ancient metropolis that never sleeps, yet never moves. The uncertainty of our own galaxy, the mystery of its dark matter, the exact shape of its hidden arms, serves as a gentle reminder that we are still learning the alphabet of the universe. We are like travelers who have only just stepped out of their front door and are already amazed by the size of the street. But the street leads to a city, and the city leads to a continent. As you settle deeper into your rest, let the Milky Way fade into the background. It is a sturdy home, and it will be here when you wake. Its 230 million year orbit will continue, unbothered and serene. The dark matter will continue to act as its silent guardian, but your mind is now free to drift further. We are crossing the intergalactic void, the vast, empty space where light travels for millions of years without hitting a single atom. It is quiet here, between the galaxies. There is nothing to see, nothing to hear, only the soft expansion of space itself. We are moving toward a light that has been traveling for 1 billion years. It is a pale yellow glow, growing larger and larger until it fills the entire field of vision. This is the light of 1 trillion souls, the light of a galaxy that has forgotten how to be small. With that in mind, let's move outward once more to an even larger scale. As we drift further from the familiar spiral arms of our Milky Way, we enter the great intergalactic desert. This is a place where distance takes on a physical weight. Between our home and the destination we seek, there are stretches of nothing so vast that entire civilizations could rise, reach the stars, and fade into dust without ever crossing the gap. In this space, the atoms are so few that you could travel for 1,000 years and never encounter a single grain of matter. It is a vacuum of such purity that it makes the air in your room feel like a dense, heavy liquid. Here, in the profound stillness of the local neighborhood's edge, we begin to realize that the universe is not made of objects, but of the space that holds them. To understand the journey we are taking, we must look back at our own cluster, the local group. It is a small, intimate collection of galaxies. The Milky Way and Andromeda are the two anchors, spinning around each other in a slow, multi-billion-year embrace. Around us are the stragglers, the Magellanic Clouds, the Triangulum Galaxy, and dozens of dwarf galaxies that look like tattered scraps of silk. This is our porch. It is a cozy corner of the cosmos. But as we move outward, the neighborhood begins to change. The gaps between the stars are replaced by the gaps between the galaxies. We are leaving the era of the individual sun and entering the era of the collective glow. Imagine the time it takes for a message to travel across this neighborhood. If you were to send a beam of light from one side of the local group to the other, it would take nearly 10 million years to arrive. Any news we receive from our neighbors is ancient by the time it reaches our eyes. We are looking at a history book written in the language of photons, and there is a deep intellectual comfort in this delay. It means that nothing in the universe happens suddenly. Everything has a long lead time. The light of the giant galaxy IC 1101, which we are now approaching, has been traveling toward us since before the first mountains on Earth were raised toward the sky. It is a light that has seen the birth of every creature that ever walked the ground beneath you. As we move further out, the individual stars of the Milky Way merge into a single, faint smudge of light behind us. Our sun is no longer visible. Our planets are gone. The entire history of humanity is contained within a speck of light that is slowly vanishing into the distance. This challenges how we think about our own importance, but it does not diminish us. Instead, it expands us. We are the consciousness that has traveled this far. We are the part of the universe that is looking back at the porch we just left. There is no urgency to return. The local neighborhood is safe. It is held in the same laws of physics that govern the giant we are about to meet. Scientists observe these distant scales by using gravitational lenses, places where the mass of a cluster is so great that it bends the light from even more distant objects, like a cosmic magnifying glass. It is as if the universe is helping us to see it. It is providing the tools for its own discovery. This suggests a sense of cosmic continuity, a feeling that the universe is not just a random collection of things, but a coherent system that wants to be understood. As we move outward, we are not moving into chaos. We are moving into a more complex form of order. The light of IC 1101 is now a dominant presence in our field of vision. It is no longer a smudge. It is a sprawling, golden continent of light. It is an elliptical giant, a structure that has moved past the frantic star-birth phase of our own neighborhood and into a state of graceful endurance. While the Milky Way is still working, busy making new stars and recycling gas, IC 1101 has finished its labor. It is a place of rest. Its trillions of stars are old, steady, and red. They move in paths that are millions of light years long. To a star in this galaxy, 1 billion years is just a season. But even with our best telescopes, there are things about this transition that remain accepted unknowns. We don't fully understand the warm, hot, intergalactic medium, the thin, invisible gas that lingers between the clusters. It is so hot that it should be glowing brightly, yet it is so thin that it is almost impossible to detect. It is a ghost of the early universe, a remnant of the fire that started it all. For now, that uncertainty is simply part of the picture. We don't need to measure every atom to feel the warmth of the cosmic breath. We can simply exist in the space between the explanations. As you drift deeper into the night, imagine yourself floating in that intergalactic void. You are halfway between our local neighborhood and the giant galaxy. Behind you is the familiar glow of home. Ahead of you is the golden orb of the deep. You are in the most peaceful place in existence. There is no gravity here to pull you down, no atmosphere to limit your vision. You are a point of awareness in a sea of infinite space. The expansion of the universe is carrying you gently forward, a silent current that moves without effort. Over immense spans of time, the light of the trillion souls in IC 1101 will wash over you. It is a light that has been purified by its journey through the void. It is a light that has lost all its shadows. In the heart of the largest galaxy, there are no dark corners. Everything is illuminated by the soft, amber radiance of ancient suns. This is the goal of our expansion, to move from the small, shadowed world of the local neighborhood into the broad, unshadowed light of the cosmic giants. With that in mind, let's move outward once more, to an even larger scale. We are leaving the porch and entering the city. We are moving from the familiar stars to the structures that hold the stars. The universe is getting larger, and we are getting quieter. There is no rush. The light has been traveling for 1 billion years. It can wait for us to drift into its embrace. The steady, unceasing flow of time and space is the only thing that matters now. The numbers are fading. The distances are merging. There is only the light, the yellow glow of 1 trillion suns, waiting to tell us the rest of the story, and it is in no hurry to finish. Now, let us take that first step away from the familiar. Let us leave the lights of Earth behind and look toward the sun, our local anchor and the first true giant in our path. To understand the vastness of the largest objects ever discovered, we must first reconcile our own physical presence with the immediate neighborhood of our star. We often think of our world as a massive, solid foundation, a place of continents and oceans that take days to cross by air and weeks by sea. But as we elevate our perspective, the Earth begins to shrink, transitioning from a world of infinite variety into a singular, fragile marble of blue and white, suspended in a velvet dark that is deeper than any night you have ever experienced on the ground. Consider the distance between your home and the Sunday. It is approximately 93 million miles. To a human mind, 93 million of anything is an abstraction, a number that sits on a page without a physical weight. But let us try to feel that distance. If you were to board a commercial jet and fly toward the sun at a constant cruising speed, you would not arrive for 19 years. You would spend nearly 2 decades in the air, crossing a silent, airless gulf just to reach the nearest star. This is the scale of our local backyard. It is a distance that defines the boundaries of our biological reality, yet in the cosmic census, it is a microscopic gap. The sun itself is the first true lesson in the universe's love for the gargantuan. It is a sphere of glowing plasma, so immense that if it were hollow, you could pour 1,300,000 Earths into it. Imagine a large glass jar filled with tiny grains of sand. Each grain is an entire world, with its own history, its own mountains, and its own billions of people, all rattling around in the bottom of a container that represents a single, average star. This comparison isn't meant to diminish the Earth, but to provide a calm place to begin our ascent. When we speak of the largest objects in the universe, we are moving towards structures that make our sun look like one of those grains of sand. Scientists understand the sun by observing its heartbeat, the way it pulses with magnetic energy and sheds its outer layers in a constant solar wind. This wind creates a bubble around us, a protective shield called the heliosphere. This is the first object we encounter that lacks a solid surface. It is a structure made of pressure, particles, and light. It reminds us that as we move outward, the definition of an object begins to change. It stops being something you can touch and starts becoming a collection of influences. The sun is not just a ball of fire, it is a gravitational anchor that holds the solar system in a steady, rhythmic dance, ensuring that the planets do not wander off into the lightless void. Astronomers often feel like cartographers trying to map an ocean while standing on a single grain of sand. We look out from our small vantage point and try to measure the height of mountains we can never climb. Beyond our atmosphere, the very concept of up and down dissolves, replaced by a sense of inward toward gravity and outward toward the unknown. As we drift away from the sun, the light begins to thin. The warmth of the hearth fades, replaced by the bracing, silent cold of the interstellar medium. This is the space between the stars, a realm that was once thought to be empty but is actually filled with the ghosts of dead suns and the seeds of new ones. Imagine walking across a frozen lake at night. The ice is thick, and the air is still. In the distance, you see the faint glow of a cabin's window. That cabin is the nearest star system, Alpha Centauri. To reach it from our sun, even at the speed of light, would take over 4 years. If you were walking at a human pace, the journey would take tens of thousands of generations. You would be born, live, and pass away in the dark, as would your children and their children, all while the destination remained a distant, unwavering point of light. This is the neighborhood of our galaxy. It is a place of immense, lonely roominess, where the objects are islands separated by oceans of silence. What makes this strange is not just the distance, but the time. Because light takes time to travel, looking into the distance is a form of archaeology. When you look at a star that is 20 light years away, you are seeing it as it was 2 decades ago. You are seeing a ghost of the past, a lingering image that has been traveling through the vacuum just to reach your eyes. This challenges how we think about now. In the universe, there is no universal now. There is only the perspective of the observer, caught in a slow-motion replay of cosmic history. As we move further out, we encounter the true giants, the stars that defy the limits of stellar physics. There are stars like Betelgeuse, a red supergiant that is so large it would swallow the orbits of Mercury, Venus, Earth, and Mars if placed at the center of our system. It is a bloated, dying sun, a majestic structure of gas that is preparing to return its material to the galaxy. These giants exist in a state of quiet equilibrium, balancing the inward crush of gravity against the outward pressure of their own light. They are the elders of the stellar community, reminding us that even the most massive objects have a life cycle, a beginning, and an inevitable conclusion. But even these stars are not the largest objects we have found. They are merely the building blocks. To find the true titans, we must look at how these stars gather together. They form clusters, and those clusters form galaxies, and those galaxies form the great filaments that weave the cosmic web. This hierarchy of scale is a fundamental rule of the universe. Small things make large things, which in turn make impossibly large things. It is a nested reality, like a series of boxes that never ends. There is a mild awe in realizing that the atoms in your own body were once forged inside the hearts of these giants. The carbon in your cells, the iron in your blood, and the oxygen you breathe were all created in the nuclear furnaces of stars that lived and died long before the Earth was even a cloud of dust. You are a part of this scale expansion. You are the universe's way of looking back at itself and saying, I am very large, and I am very old. As you lie there, let the weight of this perspective ground you. You are safely tucked away in a quiet arm of the Milky Way, far from the chaotic centers of galactic collision. You are shielded by the sun's magnetic breath and anchored by the Earth's steady gravity. The vastness of the cosmos is not a threat, it is a context. It is the backdrop against which your life unfolds, providing a sense of scale that makes your daily worries feel as light as a photon. We are preparing to move beyond the individual stars. We are going to look at the structures that hold billions of suns in their grip. We are moving toward the great attractors and the walls of galaxies that span the observable horizon. But for now, just breathe with the Sunday. Feel the slow, heavy pull of the solar system as it moves through the galaxy. There is no rush to understand the whole picture at once. The universe has been here for 13 billion years, and it is perfectly happy to wait for you to catch your breath. The definition of an object has already begun to shift in your mind. It is no longer just a stone or a tree. It is a system. It is a relationship. The largest object we've ever found is not a solid thing you could kick with your foot. It is a pattern of matter and energy so vast that it defines the very shape of space. To see it, we must continue our journey outward, past the familiar stars, into the deep, echoing halls of the superclusters. But for tonight, this human-scale perspective is enough. It is a bridge between the world you know and the universe you are part of. It is a calm, stable platform from which we can observe the infinite. Let the light of the sun, now a distant and gentle memory in the dark, be your guide as we step into the next loop of our expansion. And for now, that uncertainty, the sheer impossibility of the scale, is simply part of the picture. It doesn't need to be resolved. It just needs to be felt. With that in mind, let's move outward once more, to a scale where stars are like grains of dust, and galaxies are the only objects that matter. Dark expanse, untouched and silent, a world frozen before human ancestors ever discovered fire. Its journey inward becomes a pilgrimage, a rare awakening from an existence mostly defined by stillness. You allow that thought to settle in your mind like a snowfall, slow, quiet, inevitable. Turning your attention to the interior, you picture layers of organic molecules preserved within the ice. These molecules carry the signatures of chemistry that predates life on Earth. Some may be precursors to the building blocks of life itself. You reflect on the scientific theory that comets like this one might have delivered essential ingredients to early Earth, seeding the young oceans with materials that helped life begin. The comet becomes not just a witness to the past, but a participant in it, a traveler that may have played a role in the emergence of life. This possibility expands your sense of connection to the comet, as though its long journey is intertwined with your own story. You imagine a fragment of the comet breaking off, drifting through space, eventually falling toward Earth in some distant age. This fragment enters the atmosphere, heating briefly before landing softly on an ancient plain. Inside that fragment lies a molecule that will someday become part of something living. You feel a gentle wonder at this possibility, knowing that life is a series of connections stretching across time. The comet becomes a reminder that you, too, are part of an ancient chain, shaped by events that occurred long before your birth. As the echoes continue to unfold within you, you realize that the comet is not simply telling a story. It is inviting you to remember something about yourself. It reminds you that time is vast, that change is slow, and that endurance often comes from stillness rather than motion. You let this reflection settle softly, feeling its quiet truth expand within your chest. The ancient world carried by the comet mirrors the ancient world carried within every person, the one made of memories, instincts, and stories passed down through generations. The comet rotates slowly beneath you, revealing a cluster of crystalline ridges glinting in sunlight. These ridges formed early in its history, shaped by interactions with cosmic radiation. You imagine them as frozen sculptures, untouched since the earliest days of the solar system. Their beauty lies not in perfection, but in endurance, the way they stand unchanged despite the passage of millions of years. This endurance becomes a metaphor for the human experience, the way certain memories remain bright even after time reshapes everything else. As the comet moves steadily toward the inner solar system, you feel the echoes begin to shift again, as though preparing to lead you toward a broader view. The past is rich, deep, and endlessly fascinating, but the universe is always nudging you to expand your perspective. You sense the transition forming, a gentle widening that pulls you outward. And yet, even now, the universe seems to whisper that to understand this ancient traveler fully, You must lift your gaze from the past and look toward the vast expanse waiting beyond the horizon, where the cosmic perspective unfolds in quiet, shimmering light. And yet, even as the echoes of ancient memory drift quietly across your awareness, like frost carried on a slow wind, you feel the universe beginning to expand around you again, opening not backward, but outward, widening into something larger than history. The comet continues its patient glide, but now its presence becomes a doorway, a quiet threshold, inviting you to step beyond the intimacy of its frozen past and into the boundless stage upon which it performs its long, deliberate journey. You sense the shift, the way one notices dawn easing across a horizon, subtle at first, then unmistakable, filling everything with new light. The past was deep, but the cosmos is deeper, and your thoughts gently tilt upward, drawn toward the enormity that always surrounds you, even when you forget to look. You imagine yourself drifting farther from the comet now, giving it space so you can see it in context. It hangs like a dark, textured ember against a canvas of stars that stretch in every direction, silent and indifferent, yet somehow comforting in their vastness. The beauty of this view is not in its detail, but in its scale. Everything becomes quieter as you float here, as though distance itself has softened the noise of human thought. The comet no longer appears as a solitary traveler. It becomes part of a great, swirling choreography of planets, light, dust, and invisible forces shaping the motion of entire worlds. You feel the cosmic perspective settling into your chest like a slow, deep breath. As you rotate gently in this stillness, your gaze catches the faint glow of distant galaxies, each one a sprawling archipelago of stars. You imagine what it would be like to drift among them, each cluster containing billions of suns, each sun potentially hosting its own worlds, each world perhaps sheltering life that dreams in its own way. The scale becomes so immense that your mind cannot hold it all, yet it tries, stretching like a quiet tide to accommodate the immensity. The comet becomes a tiny note in a universal symphony, and yet a meaningful one, because even the smallest notes change the shape of the music. You feel yourself softening into this realization, allowing the enormity to calm you rather than overwhelm you. Your thoughts turn to the gravitational forces that guide the comet's immense orbit. You picture the sun not as a blinding disk, but as a soft sphere of light, pulling gently on everything around it, shaping the trajectories of planets, asteroids, dust, and icy wanderers. The sun's gravity extends far beyond sight, reaching into regions so distant that its influence feels more like a memory than a force. And yet it persists, guiding the comet inward after millions of years in the frozen outskirts. You imagine gravity as a quiet hand resting on the comet's shoulder, not pushing or pulling abruptly, but reminding it which direction home lies. You consider how this same gravitational hand shapes your own existence without you ever feeling it directly. The Earth rests in its orbit because of this cosmic choreography, spinning through space with a grace so reliable that most days you forget to marvel at it. The comet becomes a reminder that motion is universal, that everything is in continuous, unbroken movement. You feel a soft humor in the fact that humanity, so proud of its schedules and routines, lives on a planet that spends every moment hurtling through space at unimaginable speed while pretending it is sitting still. Even the quietest night is not truly quiet. It is an endless voyage through a universe that never rests. The stars shimmer more brightly as you look across the sky, revealing constellations whose shapes have been recognized for thousands of years. You imagine ancient astronomers tracing these patterns, assigning stories and gods to the stars, trying to make sense of the enormous canvas overhead. Their interpretations may have differed, but their awe was the same feeling that rises inside you now as you let the cosmic perspective widen your vision. You imagine those early stargazers sitting beside fires, pointing upward, whispering questions in languages lost to time. You feel connected to them, a quiet link forged through wonder. Your gaze shifts to the galactic plane, that luminous band stretching across the darkness. It is composed of billions of stars, dust lanes, and clouds of gas glowing softly in scattered starlight. You imagine drifting closer, weaving through massive nebulae where new stars are born. These stellar nurseries stretch across light years, immense clouds of hydrogen shaped by pressure, temperature, and gravity. The cosmic perspective reminds you that creation is not a single event, but an ongoing process, unfolding in every direction. The comet you follow was formed from similar clouds, gently drawn together into a solid body by forces so patient that they operate across eons. You imagine drifting still farther outward until the solar system shrinks to a tiny point of light. From this vantage, everything familiar becomes small, almost fragile. And yet there is something reassuring in that smallness. It reminds you that the universe is immense enough to absorb every worry, every mistake, every uncertainty. Your perspective widens until even the comet's long journey feels like a brief flicker in a great ocean of time. You sense a gentle humility rising inside you, softened by the knowledge that you are part of something vast, ancient, and ongoing. As you float in this expansive stillness, you think about the human desire to understand the universe. Scientists spend entire lifetimes studying light, gravity, motion, particles, and energy, yet the cosmos remains full of mysteries. You picture a NASA astrophysicist standing in a quiet laboratory late at night, illuminated by the glow of computer screens. They examine new data from a distant observatory, watching the comet brighten as it approaches the sun. The scientist rubs their eyes, sips cold coffee, and smiles, knowing that this small piece of information contributes to a much larger understanding. Their dedication mirrors the comet's patience, both moving steadily toward deeper revelation. The cosmic perspective deepens as you reflect on the nature of time itself. The comet moves slowly, yet its orbit spans millions of years, connecting the past, present, and future in a single arc. Time stretches differently here, becoming less linear, more fluid. You imagine watching the comet's entire orbit from above, a long ellipse drawn like a thread across the solar system. The comet is currently at one tiny point on that thread, but its path stretches far beyond what any human lifespan can encompass. This thought reminds you that your own life is part of a larger continuum, a brief moment in a story that began long before you and will continue long after. You let this understanding sink in, feeling the softness of its truth. The cosmic perspective does not diminish your existence. It enlarges it by placing it within a vast context. Every breath you take becomes part of a cosmic rhythm. Every thought, a reflection of the universe's capacity for complexity. You are made of atoms, forged in ancient stars, shaped by forces that operate across billions of years. The comet becomes a companion in this realization, a reminder that even solitary wanderers are connected to everything around them through the invisible threads of physics and time. You imagine the comet continuing its slow rotation, revealing surfaces shaped by countless encounters with cosmic radiation. Its texture tells stories that span ages, illuminated now by sunlight that has traveled across millions of miles. This sunlight carries the imprint of nuclear reactions deep within the sun's core. reactions that will continue for billions of years to come. You imagine riding a beam of sunlight from the sun to the comet, feeling the gentle warmth slipping across the frozen surface, waking ancient molecules with a soft touch. This simple interaction becomes a metaphor for awareness, the way small insights can awaken memories or stir new understanding. As your thoughts settle into this expansive calm, you begin to sense the gradual return of introspection. The cosmic perspective is vast, but the human mind eventually begins to look inward again, drawing meaning from the grand view. You feel a gentle tug guiding you back toward yourself, back toward reflection, back toward the human experience. And yet, even now, the universe seems to whisper that to understand your own place within this vastness, you must descend from the cosmic view into the quieter terrain of human meaning waiting in the next unfolding moment. We find ourselves looking at a world that challenges every notion of habitability we once held. Nature often presents us with environments that seem far too hostile for any known biological life. The silence of the void is punctuated only by the steady pulse of a dying stellar wind. Some researchers suggest that the surface temperatures fluctuate wildly between the day and night side regions. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. We continue our journey through the data to understand the true nature of this strange place. The universe remains indifferent to our desire for finding a twin of our own blue home. Every measurement brings us closer to the quiet reality of our place within the vast cosmos. We move forward now into the deeper details of the light we have recently captured. The light from Proxima Centauri takes roughly 4 years to reach your eyes. It is a journey through a quiet, cold vacuum, crossing trillions of kilometers before it touches the sensors of our most advanced instruments. You are looking at a neighbor, yet it is a neighbor shrouded in a permanent, dim twilight. The star itself, a red dwarf, is smaller and cooler than our sun, glowing with a deep ruby hue that colors everything in its reach. As we settle into this observation, notice the stillness of the data. The James Webb Space Telescope does not see colors the way you do. It sees heat. It feels the faint warmth of a planet that never turns its back to its sun. One side of Proxima b is forever bathed in that dim red glow, while the other is trapped in a perpetual, frozen night. There is no wind to carry the warmth, only the steady, silent radiation of a star that has lived for billions of years. We are watching a world in equilibrium, a balance of fire and ice that has existed long before we looked up. The sensors are calm, the transmission is steady. We are simply witnesses to a distant reality. This planet, Proxima Centauri b, resides in what we often call the habitable zone, a term that suggests comfort, but here implies a different kind of intensity. To be in the habitable zone of a red dwarf is to be very close, tucked in toward the warmth like a traveler huddled over a dying ember. The orbit is short. A year on this world lasts only 11 Earth days. Imagine the speed at which it must travel to maintain its position, a silent, rapid circling in the dark, held tight by the gravity of a star that is much older and much slower burning than our own. We watch this motion through the fluctuations in the infrared spectrum, seeing the slight dip in light as the planet passes across the face of its sun. There is a profound patience required in this science, a willingness to sit in the dark and wait for the photons to arrive, one by one, carrying the signature of a world we may never touch. The James Webb Telescope provides us with a new way of feeling this distance. Instead of blurry pixels, we now have data points that describe the energy balance of the surface. We look at the thermal phase curve, a long and gentle wave that tells us how the planet heats up and cools down as it moves. The curve is sharp. It tells us that the heat does not travel well. On Earth, our thick atmosphere acts like a conveyor belt, moving the warmth of the tropics toward the poles and evening out the sharp edges of the day. But on Proxima b, the heat seems to stay exactly where it is dropped. The day side is a fixed bullseye of thermal radiation, while the night side remains a deep, unyielding well of shadow. This tells us something fundamental about the air, or the lack thereof. It suggests a world stripped bare, a skeleton of a planet that has endured the temperamental nature of its star for eons. As we continue to watch, we must consider the nature of the star itself. Proxima Centauri is an M-dwarf, a class of star that is notoriously active in its youth. While our Sun is a steady, yellow hearth, Proxima is more like a flickering candle in a drafty room. It produces flares that are hundreds of times more powerful than anything we experience. These flares are not just light, they are torrents of X-rays and ultraviolet radiation that slam into the planet's upper layers. Over millions of years, this constant bombardment acts like a cosmic sandblaster, slowly peeling away the layers of gas that might have once protected the surface. We see the aftermath of this process in the lack of water vapor signatures. We see a world that has been refined by fire, a place where the chemistry of life as we know it would find no purchase in the parched and irradiated soil. Yet, there is a strange beauty in this desolation. When we talk about a world that terrifies, we are often just describing a place that is indifferent to our presence. The landscape of Proxima b is likely a masterwork of geology, shaped by forces we can only simulate in our labs. Without the softening effects of rain or wind, the mountains would be jagged and sharp, their peaks reaching up toward a sun that never moves. The craters from ancient impacts would remain crisp and untouched, a chronological map of the solar system's history written in stone. There is a dignity in this permanence. It is a world that does not change because it has already reached its final form. It is a monument to the endurance of matter in a high-energy environment. We find ourselves drifting deeper into the data, moving from the broad thermal maps to the finer details of the minerals. The telescope looks for the silica feature, a subtle bump in the light that would indicate the presence of rocks similar to those in our own deserts. We find traces of basalt and iron, the heavy elements that settled into the core of the planet when it was still molten and young. The chemistry is familiar, but the context is alien. On Earth, iron is the heart of our magnetic field, a spinning dynamo that protects us from the sun. On Proxima b, we do not know if such a shield exists. If the planet is tidally locked, its rotation might be too slow to generate a protective bubble. It sits exposed, a naked rock in a sea of radiation, enduring the star's gaze without blinking. This leads us to a moment of quiet reflection on the nature of habitability itself. We often search for Earth-like worlds, but perhaps we should be searching for the limits of what a world can be. Proxima b is a baseline, a testament to the extremes of the cosmos. It tells us that a planet can be the right size and the right distance, and still be a place of absolute, crystalline silence. The terror we feel is the terror of the void, the realization that life is a delicate and rare occurrence in a universe that is mostly made of radiation and vacuum. We are looking at our nearest neighbor and finding a mirror that reflects back the sheer luck of our own existence. The contrast between our green world and this red shadow is a lesson in cosmic humility. The data transmission remains steady. The telescope is a silent sentinel, orbiting a point in space, far from the interference of Earth's warmth. It is cold out there, almost as cold as the night side of the planet it observes. This shared coldness creates a resonance between the observer and the observed. We are using a frozen machine to study a frozen world. The precision is staggering. We are measuring temperature changes of just a few degrees from trillions of kilometers away. Each pixel of data is a precious commodity, a tiny spark of information that has traveled through the dark to tell us that we are not alone in the universe, even if our neighbors are made of silent stone and irradiated dust. As we transition into the next phase of our observation, we look toward the horizon of Proxima b. If you were to stand at the edge of the day side, in the permanent sunset of the Terminator line, the sky would be a deep, bruised purple. The stars would be visible even during the day because there is no thick air to scatter the sunlight into a bright blue canopy. You would see the constellations of our own sky, but they would be shifted, rearranged by the perspective of a 4-light-year journey. Our own sun would be a bright, steady star in the constellation of Cassiopeia, a small yellow dot marking the place where you were born. From there, Earth is just a memory, a tiny flicker of light lost in the glare of a much larger universe. The silence of Proxima b is not an empty silence. It is a heavy silence, filled with the history of a world that has survived the birth and middle age of its star. It is a silence that invites us to slow down, to match the pace of the cosmic clock. There is no need for fast conclusions or sensational headlines. The reality of the planet is enough. It is a world of extreme contrasts, a place of fire and ice, a neighbor that remains forever out of reach. We watch the data stream in, the long, slow lines of the infrared spectrum, and we feel the weight of the distance. The universe is vast, and we are just beginning to learn the language of the stars. The sensors are calm, the transmission is steady. We are simply witnesses to a distant reality. We watch the red dwarf glow, a steady ruby in the dark, and we wait for the next photon to arrive. There is a deep peace in this waiting, a sense of participating in a process that is much larger than ourselves. We are the eyes of the galaxy, looking back at itself, trying to understand the many ways that a planet can exist. Proxima b is one of those ways, a harsh, beautiful, and silent way. It remains there, locked in its orbit, a quiet companion in the dark until the end of time. The scale of this observation forces us to rethink our place in time. A single orbit of Proxima b is a mere heartbeat in the life of the universe. 10 days pass, and the planet has completed a journey that takes our own world a full year. This rapid cycling creates a sense of urgency in the data, a flicker of movement in the otherwise static void. Yet, despite this speed, the planet's face never changes. The same craters are always illuminated. The same plains are always in shadow. It is a paradox of motion and stillness. We are observing a world that is rushing through space at incredible speeds, yet it is trapped in a frozen state of existence, a prisoner of its own sun's gravity. As the James Webb Telescope continues its mission, it will look at other planets, other stars, and other galaxies. But Proxima b will always be special because of its proximity. It is the first step in our journey outward, the first test of our ability to understand the worlds that lie beyond our own solar system. What it found was not a second Earth, but something perhaps more important, a reminder of the diversity of the cosmos. It found a world that challenges our definitions and expands our understanding of what is possible. It found a place of terrifying beauty and profound isolation. And as we continue to watch, we find that the more we learn about Proxima b, the more we learn about the precious, fragile nature of the blue world we call home. The data remains steady. The light continues to fall on the gold mirrors. We are here, and we are watching. To understand the distance to Proxima Centauri b, imagine you are taking a very long walk. If you could walk through the vacuum of space at a steady, rhythmic pace, it would take you over 900 million years to arrive. Every step you take represents a tiny fraction of the void. If Earth were the size of a small glass marble on your table, Proxima Centauri would be another marble placed thousands of kilometers away. The planet itself is slightly larger than our own, a heavy rock hanging in the dark. If you stood on its surface, you would feel a bit heavier, your footsteps more deliberate and grounded. The sun in the sky would look much larger than ours, a bloated, dark orange disk that never sets. It would sit motionless on the horizon, casting shadows that never move, never shorten, and never lengthen. Time, there does not feel like time here. There are no Tuesdays. There are no mornings. There is only the long, unchanging now. It is a world where a shadow cast by a rock today will be in the exact same place 1,000 years from tonight. It is a slow, heavy existence, far removed from the frantic spinning of our own world. On Earth, we are defined by the cycle of the sun. We wake with the light and sleep with the dark. Our bodies are tuned to a 24-hour rhythm that governs our hormones, our moods, and our very sense of progress. But on Proxima Centauri b, that rhythm is broken. Because the planet is tidally locked, there is no rotation relative to its star. If you were to stand on the day side, the sun would hang in the sky like a heavy, unblinking eye. It does not move from east to west. It does not set. It simply exists, casting a long, still shadow that becomes a permanent part of the geography. Welcome to the grand theatre of the cosmos. Across the vast expanse of time and space, there exists a narrative that surpasses all others in scale and complexity. It is the story of everything that has ever been and everything that will ever be. Tonight, we turn our gaze upward to the infinite velvet dark to explore the fundamental forces and celestial bodies that define our existence. This journey begins not on a distant star, but right here on the blue marble we call home. Humanity has always been a species of explorers, driven by an innate curiosity to understand the lights that dance above us. From the primitive star charts drawn in caves to the sophisticated orbital observatories of the modern era, our quest for knowledge has been relentless. Consider the history of those who first dared to map the heavens. Ancient civilizations looked at the same constellations we see today and wove them into the fabric of their mythologies. creating stories that served as both guidance and philosophy. Yet, the transition from myth to science marked the true dawn of our understanding. Think of the pioneers like Galileo Galilei, who turned a crude spyglass toward the moon and forever shattered the notion that the heavens were perfect and unchanging. His courage to observe and report what he saw, despite the immense social and political pressure of his time, remains a guiding principle for every astronomer today. We stand on the shoulders of these intellectual giants, using the principles of physics they helped define to unravel the mysteries of the universe. The cosmos is a realm governed by strict physical laws, yet it remains profoundly mysterious. When we discuss the nature of our universe, we must speak of gravity, the invisible architect of all things. It is gravity that pulls dust and gas together to form the first stars, and it is gravity that dictates the orbital dances of planets and moons around their host stars. In the heart of many galaxies lie the most extreme manifestations of this force, known as black holes. These objects are regions of space where gravity is so intense that nothing, not even light itself, can escape their grasp. They are not merely destructive voids, but essential components that shape the evolution of the galaxies they inhabit. The study of black holes challenges our understanding of reality, forcing us to reconcile the predictable laws of classical physics with the strange behavior of matter near the event horizon. To observe these phenomena, we have moved beyond the limits of human eyes. We have built monumental facilities designed to peer deeper into the fabric of space and time. Agencies around the globe now coordinate massive engineering feats, constructing telescopes that act as time machines. By capturing light that has traveled for billions of years, these instruments allow us to witness the universe in its infancy. The James Webb Space Telescope is perhaps the most significant achievement in this endeavor. Designed to observe the infrared spectrum, it pierces through the dense clouds of interstellar dust that once hid the birth of stars and planetary systems from our view. Each image captured by this observatory is a dataset that refines our models of galaxy formation and chemical evolution. Consider the complexity of our own solar system. It is a diverse neighborhood of planets, moons, asteroids, and comets, each telling a unique story of formation and change. We have sent robotic emissaries, our rovers, to traverse the desolate and fascinating surface of Mars. These machines are the robotic pioneers of our time, drilling into rock and analyzing soil to search for signs of past life and to understand the geological history of a world that was once far more active than it is today. Every transmission sent back from these rovers is a triumph of engineering and a testament to the persistent human drive to seek out the unknown. They operate in harsh conditions, powered by the sun and steered by researchers who feel the weight of every command sent across the millions of miles of vacuum. The science of cosmology addresses the biggest questions of all. How did the universe begin, and how will it end? Current evidence points to a colossal expansion that began roughly 13.8 billion years ago. Since that moment, the universe has been growing and cooling, allowing for the formation of the complex structures we observe today. We live in an era where we can measure the cosmic microwave background, the afterglow of the Big Bang, which provides a snapshot of the universe when it was only a few 100,000 years old. This, combined with our observations of dark matter and dark energy, suggests that we see only a small fraction of what actually constitutes the cosmos. The vast majority of our universe is made of components we cannot directly perceive. Yet we know they exist by the way they influence the movement of galaxies. The collaborative nature of modern astronomy cannot be overstated. It is a global endeavor that transcends borders, languages, and political divides. When we study the life cycle of stars, we are observing the factories that created the very atoms that make up our own bodies. Every carbon atom, every oxygen molecule, and every trace of iron in our blood was forged in the hearts of stars that died long before our solar system was even a glimmer in the cosmic dust. We are, quite literally, made of star stuff. This realization connects us to the history of the universe in a profound way. We are the mechanism by which the universe has become conscious of itself. Think of the technological advancements that have trickled down from our space exploration efforts. The materials science required to protect spacecraft, the complex computer algorithms used to process data from distant reaches of the galaxy, and the breakthroughs in energy efficiency are all results of the challenges faced when we push the boundaries of what is possible. By attempting to understand the environment of space, we have become better stewards of our own environment here on Earth. The perspective gained from seeing our planet as a fragile blue sphere suspended in an immense dark void has influenced our culture, our politics, and our environmental policies. As we look toward the future, the possibilities are limited only by our imagination and our commitment to exploration. We are planning missions to explore the icy moons of Jupiter and Saturn, where hidden oceans might harbor the conditions necessary for life. We are refining our techniques to detect exoplanets, searching for another world that might share the characteristics of our own. The search for extraterrestrial intelligence continues to evolve as we listen for signals from across the interstellar divide. Even if we find that we are alone, the search itself is worth the effort, for it teaches us more about the uniqueness and the value of the life we have already found. The beauty of the universe is not just in its vastness, but in its mathematical elegance. The patterns we see in the spiral arms of a galaxy are reflected in the growth of biological structures on Earth. The laws of motion that govern a planet in its orbit are the same laws that dictate the trajectory of a falling apple. This interconnectedness is the foundation of physics, the language that allows us to translate the silence of the stars into a coherent story. We are not separate from the universe. We are a vibrant, active, and curious part of it. As we continue this exploration, we must always remember the importance of fundamental research. Much of what we know today began as theoretical curiosity, a question asked by a scientist who wondered why things worked the way they did. The transition from theoretical wonder to technological application is the engine of human progress. When we invest in astronomy and space physics, we are investing in the expansion of human knowledge, which is the most valuable commodity we possess. The challenges are undeniably great. The distances are unfathomable, the conditions are hostile, and the timescales are beyond the capacity of human experience to truly comprehend. Yet, we persist. We build better telescopes, we design faster rockets, and we train the next generation of scientists to take up the mantle. There is a sense of wonder in knowing that there is so much left to discover. The universe is not a closed book. It is an open exploration that rewards the curious and the patient. Consider the role of the modern astronomer. They are no longer just people looking through eyepieces. They are data scientists, engineers, and visionaries who work with vast arrays of sensors and computer networks. They navigate the complexities of international cooperation to ensure that the findings of one are shared with all. This spirit of sharing is the heartbeat of science. It is why we can speak of these things today, and why we can look forward with anticipation to the discoveries that will be announced tomorrow. In concluding this reflection on our place in the cosmos, consider the responsibility we hold. We are the current witnesses to the history of the universe. We have the capability to look back in time and the technology to project our reach into the future. Whether we are studying the formation of planets, the cooling of white dwarfs, or the expansion of the dark energy that permeates the void, we are engaging in the most noble of human endeavors. We are seeking to understand the truth of our origins and the nature of our destiny. So, let us keep our eyes on the stars. Let us continue to support the agencies and the individuals who dedicate their lives to exploring the unknown. The next great discovery might be just beyond the next horizon, hidden in the data of a telescope or revealed by the sensors of a probe. The universe is waiting to be understood, and we are ready to listen to its story. Through our combined efforts, through the relentless application of logic and the burning flame of curiosity, we will continue to push back the boundaries of the dark and fill the map of the unknown with the light of knowledge. This is the enduring legacy of the human spirit, a spirit that refuses to be confined to the ground, a spirit that insists on reaching for the heavens to find its true place among the stars. The journey is far from over, and the best parts of the story are yet to be written. Everything that we have discussed, from the smallest particle in a laboratory to the largest structure in the universe, is part of one singular, grand, and beautiful process. It is a process that we are honored to participate in and privileged to understand. May our pursuit of this understanding never cease, for in the light of the stars, we find the reflection of ourselves. The chronicle of our exploration continues, pushing deeper into the tapestry of the night sky, where the rules of the macrocosm unfold in grand displays of energy and matter. When we contemplate the life cycle of stars, we are witnessing a narrative of birth, maturity, and inevitable transformation. From the vast, cold clouds of molecular gas that collapse under their own gravity to the violent, brilliant supernovae that seed the galaxy with heavy elements, the process is one of constant renewal. Each star acts as a cosmic furnace, synthesizing elements in its core through the process of nuclear fusion, balancing the inward pull of gravity against the outward pressure of radiation. When a massive star reaches the end of its lifespan, it undergoes a spectacular collapse, creating the elements essential for life and scattering them across the interstellar medium, which will eventually form the next generation of stars and planetary systems. This cycle is the fundamental mechanism of chemical evolution, turning the simple hydrogen and helium born in the first minutes of the universe into the complex chemistry that allows for life to emerge. Beyond the stars, we turn our attention to the structure of galaxies themselves. Whether they are spiraling disks adorned with glowing dust lanes and clusters of young blue stars, or elliptical collections of ancient red stars, each galaxy is a gravitationally bound city of billions of individual suns. Our own Milky Way is a barred spiral, a massive entity that houses our solar system in one of its quieter suburbs. Understanding how these massive structures grow and interact requires us to look at the large-scale architecture of the universe, where galaxies are organized into clusters and superclusters. connected by filaments of dark matter that form the cosmic web. This web is the scaffolding upon which the visible matter of the universe is hung, and mapping it is one of the primary goals of modern observational cosmology. Consider the role of dedicated space observatories in mapping this web. Telescopes, such as the Hubble Space Telescope, have provided us with iconic views of distant galaxies, allowing us to estimate the age of the universe with remarkable precision. By measuring the recession velocity of these galaxies and their distance from us, astronomers have been able to confirm the expansion of space itself. This expansion is not merely galaxies moving apart through static space, but the stretching of the very fabric of space and time. Furthermore, the discovery that this expansion is accelerating has led to the inclusion of dark energy in our cosmological models. Dark energy, an enigmatic force that seems to act as a repulsive pressure, dominates the energy budget of the universe. While its exact nature remains one of the greatest unsolved problems in physics, its presence determines the ultimate fate of everything we see. The study of planets, both within our solar system and beyond, offers a different perspective on our place in the universe. Within our neighborhood, the diversity is startling. We have rocky inner planets with active volcanoes and tectonic plates, and gas giants that function as miniature solar systems with their own complex moons. Exploring these worlds is a matter of planetary science, a field that uses the data from orbiters and landers to reconstruct the history of environmental conditions across billions of years. We look for evidence of past liquid water, for signs of geological activity, and for the chemical precursors that might suggest an environment conducive to life. Each discovery on Mars, on Europa, or on Enceladus recalibrates our understanding of how unique, or perhaps how common, the conditions for life might be. When we look beyond the solar system to exoplanets, we enter the realm of statistics and atmospheric analysis. By observing the slight dimming of a star as a planet transits in front of it, or measuring the subtle gravitational wobble of a star induced by an orbiting companion, we have confirmed the existence of thousands of worlds. Some are scorched giants orbiting perilously close to their host stars, while others reside in the habitable zone where temperatures might allow for liquid water on the surface. Future missions are being designed to perform spectroscopy on the atmospheres of these distant worlds, seeking signatures of oxygen, methane, and other gases that could indicate biological activity. This is the search for life at a truly interstellar scale, a project that bridges the gap between planetary science and biology. Let us also acknowledge the scientists who spend their lives refining these theories. The work of an astronomer is not limited to observation. It is deeply rooted in the rigorous application of mathematical models and computational simulations. Using supercomputers, theorists model the complex dynamics of gas, the gravitational interactions of thousands of bodies, and the influence of magnetic fields on plasma. These simulations allow us to test hypotheses that would be impossible to verify in a laboratory setting. They enable us to see how a galaxy evolves over billions of years, or how a black hole tears apart a passing star. The synergy between observation and simulation is what drives the progress of modern science. It allows us to move from simply cataloging the contents of the universe to understanding the underlying mechanisms that create them. Historical perspective reminds us that our current understanding is only the most recent chapter. The transition from the geocentric view, where everything orbited the Earth, to the heliocentric model was a revolution that changed humanity's self-perception. Today, we are undergoing a similar shift, moving from a view of a static universe to one that is dynamic, expanding, and composed mostly of components we do not yet understand. This journey of discovery is marked by monumental technical hurdles, from the challenges of atmospheric interference that necessitated the launch of space telescopes, to the extreme engineering required to keep rovers operating on a freezing Martian surface. The history of space exploration is a history of overcoming the impossible through human ingenuity. Consider the international collaboration that defines the current era. Major facilities are rarely the work of a single nation alone. They represent the combined efforts of thousands of engineers, scientists, and technicians from around the world. These projects foster peace and cooperation, providing a common goal that transcends cultural and political differences. When we share the data from a satellite or a ground-based array, we are contributing to a global pool of knowledge that benefits all of humanity. This spirit of cooperation is essential, as the challenges of the future, such as the construction of permanent lunar bases or the long-term exploration of the outer solar system, will require resources and expertise that no single entity can provide on its own. We must also appreciate the sheer scale of the challenges posed by the universe. Radiation, vacuum, extreme temperatures, and the vast distances between stars make space an inherently hostile environment. Yet, it is this very hostility that drives innovation. Every material developed to withstand the heat of re-entry, every sensor designed to operate in the intense radiation environment of Jupiter, and every power management system built to run on the thin energy of a distant sun represents a breakthrough that improves technology here on Earth. Space exploration is a crucible for progress, pushing us to solve problems that we did not even know we had. The philosophical implications of our findings are equally profound. Knowing that we live in a universe governed by consistent physical laws, from the scale of the atom to the scale of the galaxy, gives us a sense of belonging. We are part of a rational, ordered system that can be studied and understood. This does not diminish the mystery or the beauty of the cosmos. Rather, it enhances it. The more we know about how the universe works, the more we can appreciate the complexity and the elegance of the phenomena we observe. From the way light bends around a massive object to the way a star dies, everything follows a path defined by the fundamental forces of nature. As we continue to advance, we must prioritize the cultivation of curiosity in the next generation. The scientists and engineers of tomorrow are currently in classrooms, looking at images of the cosmos and wondering how it all works. Providing them with the tools, the education, and the inspiration to pursue these questions is the best investment we can make. We must share the stories of our failures and our successes, showing that science is not just a collection of facts, but a process of questioning, experimenting, and refining our models of reality. It is a process that requires resilience, skepticism, and, above all, a deep, abiding wonder. Think of the dark skies away from city lights, where the band of the Milky Way is clearly visible. That view has been the constant companion of humanity throughout our history. It has inspired poets, philosophers, and scientists alike. In those moments of quiet contemplation, we are reminded that we are small, yet we are capable of understanding the vastness that surrounds us. That is the true miracle of our existence. We are the universe observing itself, questioning itself, and seeking to understand its own origin. This realization brings with it a sense of stewardship. We have only one home planet, and as we look out into the void, we are reminded of how rare and precious the conditions on Earth truly are. The future of astronomy and space science is limited only by our willingness to explore. Whether we are launching the next generation of space telescopes that will look back even further in time, or deploying robotic fleets to map the asteroids that could provide the resources for further expansion, we are constantly expanding our reach. The data we collect today will be the foundation for the theories of tomorrow. We are laying the groundwork for a future where humanity is not just a spectator of the cosmos, but a participant. A future where we understand not just what the universe is, but how we fit into its long and complicated history. In concluding this exploration, let us reflect on the enduring nature of our quest. We started with the primitive observation of the heavens, and we have moved to the sophisticated analysis of cosmic radiation, black holes, and the accelerating expansion of space. Each step has brought us closer to the truth, and each step has revealed that the universe is far more complex and interesting than we could have imagined. There is no finish line in science. There is only the continuous process of asking better questions and finding more precise answers. The darkness of space is not a void to be feared. It is a canvas upon which we are painting the picture of our understanding. Let us remain steadfast in our dedication to this noble pursuit. Let us continue to look up with wonder and to build with purpose. The universe is patient, and it will continue to reveal its secrets to those who have the courage to ask and the persistence to seek. From the smallest subatomic particles to the largest clusters of galaxies, the entire story of the universe is written in the language of physics, and it is a story that we are slowly, patiently learning to read. We are the explorers of the infinite, and our journey has only just begun. The beauty of the stars, the mystery of the deep space, and the promise of discovery are waiting for us. All we have to do is keep looking up, keep learning, and keep reaching for the vast potential that lies among the stars. Our history is a testament to what we can achieve when we work together, and our future is a blank page waiting for the discoveries that will define the next great era of human exploration. The stars are calling, and we are finally learning how to answer. In the end, we will find that we are connected to every part of the cosmos, from the atoms in our cells to the light of the most distant quasar. We are all part of one grand, magnificent, and eternal design that continues to unfold before our very eyes. We have the privilege of witnessing this, of analyzing it, and of sharing it. And that is a responsibility that we must carry forward with pride and determination. Our quest for knowledge is the defining characteristic of our species, and it is the key that will unlock the mysteries of the universe, one observation at a time. May we always be guided by the light of discovery, and may our collective spirit continue to drive us toward the horizons that have yet to be explored. The story is ours to tell, and the future is ours to build. Let us continue to explore, to learn, and to grow as we make our mark on the cosmos and find our true place among the infinite lights of the night sky. When we think about the largest galaxy in the universe, we often imagine it in human terms. We try to use distances we can walk or time we can measure in years. But human scales are like a small candle held up against a vast, dark ocean. To understand where we are going, consider a simple walk. If you were to walk at a steady pace, without stopping for sleep or food, it would take you about a year to walk the circumference of the Earth. That feels like a significant distance, a long, weary journey across continents and seas. Now, imagine that journey scaled up. If you were to drive a car at highway speeds toward the sun, it would take you about 193 years to arrive. Multiple generations of your family would be born and grow old within that car before the dashboard clock reached its destination. That is just our local neighborhood. When we talk about galaxies like IC 1101, our human measurements, miles, kilometers, even the distance to the sun become almost humorous in their inadequacy. They are like trying to measure the volume of the Pacific Ocean using a single teaspoon. This comparison isn't perfect, but it gives us a calm place to begin. It allows us to recognize that our smallness isn't a limitation, but a starting point for wonder. To understand the giant, we must first understand the grain of sand. We must look at the tools we carry in our pockets, the rulers, the clocks, and the maps, and realize that they were designed for a much smaller house. Consider the simple act of walking. For a human, a walk across a meadow is a pleasant way to spend an afternoon. A walk across a continent is a feat of legendary proportions, something that would take months of steady, rhythmic effort. If you were to set out on foot to circle the entire Earth, you would be walking for nearly a year without rest. Your shoes would wear thin, the seasons would change around you, and by the time you return to your starting point, the world would have aged. To us, the Earth is the definition of vast. It is the horizon that never ends, the solid ground that holds everything we have ever known. But if we step just 1 inch away from the Earth's surface, our perspective begins to stretch. Imagine a car traveling at a steady speed on a long, straight highway. If that highway led to the moon, you would be driving for about 6 months. It would be a quiet trip, a long period of looking out the window at the approaching white sphere. But if you turned that car toward the sun, the journey would change. To reach the sun at highway speeds, you would need to drive for 193 years. You would not finish the trip. Your children would not finish the trip. It would be your great-great-grandchildren who finally felt the warmth of our star growing closer. This is the scale of our local neighborhood, a distance that already exceeds the span of a single human life. Yet, even this 193-year journey is a microscopic flicker. To a galaxy like IC 1101, the distance between the Earth and the Sun is practically zero. It is a rounding error. It is the thickness of a single coat of paint on a skyscraper. When astronomers look out into the deep field, they have to stop using miles and kilometers entirely. These numbers become too heavy to carry. They have too many zeros. They clutter the mind and lose their meaning. Instead, they use light. Light is the fastest traveler in the universe, moving at 186,000 miles every single second. In the time it takes you to blink, light has already circled the Earth 7 times. It is a speed so fundamental that it defines the rhythm of existence. To light, the trip to the moon takes a little over 1 second. The trip to the sun takes 8 minutes. If the sun were to suddenly go dark, we would continue to live in its warmth and light for 8 minutes, unaware that the source had vanished. We are always living in the recent past. But even light, as fast as it is, begins to feel slow when we look toward the larger structures of the universe. To cross our own galaxy, the Milky Way, light must travel for 100,000 years. This means when we look at the stars on the far side of our home, we are seeing them as they were when early humans were first beginning to use stone tools. We are looking at a ghost of a time we cannot remember. Now, hold that 100,000-year journey in your mind. It is a vast stretch of time, spanning the entire history of our species. And then, consider IC 1101. This galaxy is so large that light requires 6 million years to cross it. 6 million years. When a photon of light begins its journey at one edge of IC 1101, our ancestors on Earth were not yet human. They were distant relatives, wandering the forests of Africa. By the time that photon reaches the other side of the galaxy, civilizations have risen, built pyramids, invented electricity, launched satellites, and perhaps faded away. The galaxy is so wide that it contains the entirety of human evolution within a single crossing of a light beam. This scale is not meant to be frightening, it is meant to be a release. When we realize that a single object can be so large that it dwarfs our entire history, our daily anxieties begin to lose their weight. The deadlines, the small worries, the brief tensions of a Tuesday afternoon, they do not exist on the scale of 6 million light years. They are absorbed by the golden glow of 1 trillion stars. In the Abell cluster, where IC 1101 resides, time moves with a different gravity. It is a slow, heavy time that does not care for the ticking of a wristwatch. Think of a single star in our sky. It is a massive, burning ball of plasma, millions of times larger than the Earth. Now imagine 100 billion of those stars. That is our Milky Way. Now, try to imagine 100 trillion stars. That is the population of IC 1101. If every star in that galaxy were a single grain of sand, you would have enough sand to fill a beach that stretches across the entire planet. Not just one coastline, but every continent, every desert, every mountain, covered in a thick layer of stars. And each of those stars is a sun, potentially holding planets, moons, and rings of ice. We often imagine galaxies as flat spirals, like the ones we see in textbooks, but IC 1101 is an elliptical galaxy. It is a great, swollen orb of ancient light. It doesn't have the youthful, frantic energy of a spiral galaxy with its new stars and bright blue gas. It is a collection of old souls, red and yellow stars that have been burning for 10 billion years. It is a retirement home for suns. It is calm. It is stable. It has reached a size where it no longer needs to rush. It simply sits at the center of its cluster, a gravitational anchor for thousands of other smaller galaxies that orbit it like moths around a campfire. To understand the mass of such a place, we have to think about gravity. Gravity is the quietest force, but it is the most persistent. It is the shepherd of the stars. In a galaxy as large as IC 1101, gravity is so strong that it bends the path of light itself. It pulls on the very fabric of space, creating a well so deep that anything nearby is eventually drawn in. Over billions of years, IC 1101 grew to its current size by eating other galaxies. It is a slow-motion consumer. It doesn't hunt, it simply waits. Smaller galaxies, distracted by their own internal dances, eventually drift too close. They are stretched, pulled apart, and woven into the golden fabric of the giant. This is not a violent act in the cosmic sense. It is a merger. It is a way for the universe to organize itself into larger and larger patterns. If you were standing on a planet in the middle of IC 1101, the night sky would not look like ours. Here on Earth, we see a few thousand stars and the dark, dusty band of the Milky Way. In the heart of the giant, the sky would be a solid, glowing canopy. There would be no true darkness. The density of stars is so high that the night would be as bright as a permanent twilight. You would be surrounded by the light of 1 trillion suns, a warm amber glow that never fades. It would be a world without shadows, a place of infinite, soft illumination. But from our distance, IC 1101 is just a smudge of light in a telescope. It is a quiet reminder that the universe is capable of making things we cannot fully name. We call it a galaxy, but the word feels too small. It is a continent of light. It is a reservoir of history. It is a place where the laws of physics are the same as they are here, but the results are vastly more ambitious. As you lie here, safe and still, let the image of this golden giant rest in your mind. You are not required to measure it. You are not required to cross it. You are simply invited to acknowledge that it exists. Like a mountain in the distance or the deep currents of the sea, it is there, whether we watch it or not. It moves with a slow, heavy grace, orbiting a center we can only guess at, participating in a cosmic cycle that spans billions of years. The teaspoon and the ocean, the grain of sand and the beach, the human and the galaxy, we are the small observers of the very large. And there is a profound peace in being small. It means we don't have to carry the weight of the universe. We don't have to manage the orbits of 1 trillion stars. We can simply drift. We can allow the scale of the giant to remind us that the universe is vast enough to hold all of our mysteries, all of our questions, and all of our silence. Scientists understand IC 1101 by watching the way the galaxies around it move. They see the dark matter that must be there to provide the extra gravity needed to hold such a massive structure together. They see the intracluster light, a faint, ghostly glow between the galaxies where stars have been stripped away from their homes and now wander the void alone. It is a complex, beautiful system, but at its heart, it is simple. It is a collection of light, held together by the same forces that keep your feet on the floor. Over the next few hours, we will move closer to this giant. We will look at its stars, its history, and its eventual fate. But for now, stay here in the human scale. Stay with the breath. Stay with the quiet. The giant is far away, and it is moving slowly. It is patient. It has been waiting for 6 billion years for its light to reach you. It can wait a little longer while you rest. Ba, va. Everything is in its place. The earth is beneath you. The moon is above you. And the largest galaxy we've ever found is out there, glowing softly in the deep, a golden anchor in the dark. It is not a place of chaos, but a place of incredible ancient order. And as we begin our slow expansion outward, we do so with the knowledge that we are safe in our smallness, drifting in a universe that is far too big for anything but peace. To find comfort in this vastness, we must return to the simple things. We understand the weight of a hand, the length of a step, and the steady passage of the seasons. These are our anchors. Without them, The scale of IC 1101 would be too heavy to hold, but with them, it becomes a beautiful, distant horizon. Consider, for a moment, the concept of a neighborhood. In our daily lives, a neighborhood is a collection of streets, a few houses, and perhaps a park where the trees change color in the autumn. It is a place where you know the distance from your front door to the corner store. If you were to walk that distance, it might take you 5 minutes. In those 5 minutes, your heart beats a few hundred times, and the world remains exactly as you expect it to be. This is the scale at which we are designed to function. Our eyes are tuned to see the texture of a leaf or the expression on a friend's face. We are creatures of the local and the immediate. Now, imagine if we were to expand that neighborhood. If we look up at the moon, we are looking at an object that is roughly 238,000 miles away. To a human, that number is abstract. It is just a 2 and a 3 and an 8. But if you were to attempt to walk to the moon, it would take you nearly 9 years of continuous, non-stop effort. You would walk through every season 9 times. You would watch the constellations shift slightly in the sky. By the time you arrived, the world you left behind would have moved on. And yet, on the cosmic map, the moon is so close, it is practically touching us. It is the very first step on a staircase that has billions of flights. When we talk about the distance to the sun, the scale shifts again. It is 93 million miles away. If you were to fly in a commercial jet toward the sun, you would be traveling for 19 years. 2. Think of all that can happen in 19 years, the way children grow, the way cities change, the way we evolve as people. All of that time spent in a single straight line just to reach our own local star. This is the human scale, trying to grasp the solar scale. It is a stretch, but we can still just barely imagine it. We can look at the sun and feel its warmth on our skin, a physical connection to a journey that would take 2 decades to complete. The golden anchor of IC 1101 is always there, even when the sun is out and the sky is blue. It is there, glowing with the light of 100 trillion suns, silently holding its part of the cosmic web together. It does not demand our attention. It does not require us to understand its physics. It simply performs its role in the ancient order. It is a place of peace because it has already reached its final form. It is no longer struggling to grow. It is no longer burning with the hot blue fire of youth. It has settled into a state of graceful amber maturity. The universe is far too big for anything but peace. This is the ultimate lesson of the largest galaxy we've ever found. It is so big that conflict is impossible. It is so big that time is irrelevant. It is so big that silence is the only language that fits. And in that silence, we find our rest, we find our place. The golden anchor is waiting, the deep is calling, and we are safe in our smallness, drifting slowly into the heart of the ancient order. The motion continues without any signs of a final conclusion or end. Beyond the visible horizon of space galaxies are undoubtedly spinning in the dark. The cosmic web stretches out infinitely, carrying this momentum into the unknown. There is no central point that anchors the entire universe in place. Instead, everything turns relative to everything else in a continuous network of motion. This interconnected spinning creates a stable framework that defines the nature of space. The spin is the fundamental fabric upon which reality is woven. As you listen to the description of these vast movements, your mind relaxes. The repetitive nature of cosmic rotation offers a gentle rhythm for sleep. You can visualize the slow, majestic turning of galaxies far out in the dark. They spin without effort, generating no sound in the perfect vacuum. The stars move silently, traced by faint paths of ancient silver light. This movement has no beginning that we can clearly see, and no end. It is a permanent feature of existence that requires nothing from us. The universe keeps turning, while the night deepens around you completely. The planets rotate on their axes, and the sun journeys through the galaxy. The galaxy slides smoothly through the local group of cosmic structures. This movement is happening right now as you drift into quiet rest. It will continue tomorrow and for all the millions of years that follow. The rotation is a gentle guarantee of continuity across the deep cosmos. You are safe within this turning world, floating effortlessly through the dark. The motion flows onward, endlessly fading into the quiet background of space. The motion continues without any pause or hesitation, drifting smoothly through the dark hours of the night, like a quiet ship sailing across a calm, featureless sea. The planets turn, the sun journeys through its galactic track, and the Milky Way slides gracefully through the local group of cosmic structures. This movement is happening right now, during this very breath, guiding you deeper into a state of total rest and relaxation. It will continue tomorrow, and for all the millions of years that lie ahead, an unbroken thread of physical continuity that connects the past, present, and future into a single, beautiful system. You are completely safe within this turning world, floating effortlessly through the vast dark spaces of the cosmos, while the motion flows onward, endlessly fading into the quiet, permanent background of space.